So let's talk a little bit about prescriptive and descriptive analytics and how AI is going to impact those. So the last revolution really was about big data. And big data enabled us to get a ton of analytics, especially when you're dealing with IoT networks and so forth. These all the data coming from your sensors and so forth. And what has happened is we've needed to get a group of people called data scientists and analysts, and they've had to come in and look at all this data coming into the companies, and then they have to analyze it and then give you prescriptive, being what's going to happen in the future, and then even descriptive, describe what all that data is through their analysis. So here's the problem with that right now, is that you have your senior level people, and they're in between that feeding data, and these are decision makers. And then you have your people that are working on the line, the everyday working, and they have to depend on the interpretations from this group of analysts and data scientists. So what you've done is you've created this layer of bureaucracy and so forth, and it's getting more expensive and everything else on the data that has to do with that. So the ROI diminishes over time that people have invested in to get this big data. So the answer really has been AI. And AI has two solutions to this. One's called a visual language model, and we'll talk more about that, and then liquid neural networks. So let's start out with the VLM. So what is a VLM, or visual language model? A VLM is where you combine text and you combine vision data. And what the VLM's able to do, just like with ChatGPT and other things, it's able to tell you what's going on in that image through language. What the VLMs enable is removing this layer of bureaucracy that's in there and getting the data and the context and the descriptions and so forth to people in senior management and people that are working on the line. So it's democratizing your predictive and descriptive analytics capabilities. What it takes is a lot of annotation, and it causes two areas of annotation, not just on the visual side of the data, but also on the textual, and bringing those two together within context. So it's very expensive to create one of these. And if we look at it, so let's just talk a little bit about, so your regular, talking about numbers of neurons and things like that are in these things. So that you could have billions of neurons in these. And so it makes it really hard to track why something is making a decision within networks. Within machine learning networks. It's a big problem. So why did it come to this decision? Well, if you have that many neurons in the system, it's very hard to track why it's making decisions. You hope that your data is leading it to those correct decisions and so forth. So traceability becomes a factor, especially as you go to predictive. So why did that happen, right? We don't know. We can't trace back why it made those decisions. The people at MIT University found this very difficult situation and thought it was hard if you're going to implement something that's autonomous, like a self-driving car. So they looked for different types of networks than these VLMs and large language models and so forth to be used in the situations like autonomous driving or an IoT, where you have a certain data type that's called time series data. So they came up with a set of networks called liquid neural networks, which is what we are embracing at alwaysAI. And they're called liquid neural networks because they're liquid in that they're not really defined in shape, so they're highly dynamic, meaning they can work non-linearly. They also rely on anywhere from 16 to 100 neurons. So compare that to 1 billion to 16 and 100. So what does that mean? It means that these dynamic networks are traceable of why they're making decisions. So what happens is a person could sit there and say, well, why are you making this decision on a machine or this prediction in the future? And what that tells us, what they can do is then trace back the logic of why the network's making that decision. It's also dynamic. So let's say that you have a change in the environment. Again, we're talking about autonomous vehicles here, but you could put it into mining. So mining will go through cycles and so forth. You need to understand those cycles. It's not going to be this pure linear situation where, hey, we're going to see things coming out of the mine all the time. There's going to be a switch as it diminishes down and as they go to blasting new shafts and so forth. So you won't have a continuous linear production. So these type of models will help us understand that and make prediction capabilities that the people in the field that are staffing understand that and the workloads, but also the senior management that's modeling this. And you can trace back to why the model is making this decision. So that's really important, the audit trail behind it. So what does that do? You don't need the people that are doing all the planning anymore in your networks and so forth. And you're freeing up that data again and democratizing it. So again, liquid neural networks, they're fast, they're real time, and we can figure out what they're doing. And they can handle nonlinear situations that are really important in the IoT world and in mining and manufacturing and so forth.